Imagine waking up one morning on a planet where the air feels fresher. The biodiversity explodes with colors you've never seen, and life thrives so easily that evolution seems to hit the fast-forward button. No more worrying about climate tipping points or resource shortages. Nature just handles it better. Sounds like a dream? Well, scientists aren't just dreaming. They're hunting for these places right now. Earth is an incredible home. It's got the perfect mix of liquid water, a protective magnetic field, and a stable star. But what if there are worlds out there that check all those boxes, and then some? Places older, slightly warmer, and more biologically generous than our blue marble. These aren't just habitable, they're superhabitable today. We're diving into the most promising super-Earth candidates that could outshine our planet for supporting complex life. Stick around, because by the end you might start wondering if packing our bags for the stars is the ultimate backup plan. Let's explore why some distant worlds might actually be upgrades. First, let's break down what superhabitable even means. It's not just marketing hype from astronomers, it's a serious scientific framework. A habitable planet sits in the Goldilocks zone, not too hot, not too cold, with potential for liquid water. But superhabitable goes further. Researchers look for planets that give life every possible advantage, making it easier for complex organisms to evolve and flourish over billions of years. Key factors include age. Our solar system is about 4.6 billion years old, and it took roughly 4 billion years for complex life to really take off here. Planets aged 5 to 8 billion years old might have had that extra head start more time for stable climates, diverse ecosystems, and maybe even intelligent life to develop without the rush. Think of it like a garden that's been tended for centuries versus one you just planted last spring. The older one is lush and self-sustaining. Size matters too. Ideal superhabitable candidates are roughly 1 to 1.5 times Earth's mass and about 10% larger in radius. Why? A bit more mass helps retain internal heat longer, powering plate tectonics that recycle nutrients and stabilize the atmosphere. That slight size bump could mean stronger gravity holding on to a thicker atmosphere, protecting against radiation and helping maintain mild temperatures. If the average surface temp sits around 5 degrees Celsius warmer than Earth's, say, a cozy global average of 20 to 22 degrees Celsius biodiversity could skyrocket. Warmer, wetter conditions often support rainforests teeming with life, much like how tropical zones on Earth burst with species compared to polar regions. This isn't sci-fi wishful thinking. It highlights how finicky Earth's conditions really are. We've had ice ages, asteroid impacts, and volcanic catastrophes that nearly wiped the slate clean. A superhabitable world might buffer those extremes better, with more water coverage distributing heat evenly, or a more forgiving atmosphere shrugging off solar flares. But here's the reality check. Detecting these traits from light years away is insanely difficult. We rely on indirect clues like starlight dimming during transits or atmospheric spectra. It's like trying to judge a book's quality by peeking through a keyhole. Adding depth from broader exoplanet research. Many astronomers emphasize that superhabitability favors K-type dwarf stars over our G-type sun. These orange dwarfs burn steadier and longer, up to 70 billion years, giving life eons more runway. Red dwarfs, while common, come with flare risks that could strip atmospheres or bombard surfaces with UV radiation. So, the sweet spot, a stable, long-lived star with a rocky planet in just the right orbit. Let's make this concrete with some real-world parallels and hypothetical stories. Picture this. You're a paleontologist on a future mission to one of these candidates. Back on Earth, we study ancient sites like the Burgess Shale in Canada, where a sudden mudslide 500 million years ago preserved an explosion of bizarre Cambrian life forms, creatures with eyes on stalks and weird appendages that show how quickly evolution experiments when conditions allow. Now translate that to a superhabitable exoplanet slightly older and warmer. Life might not have needed those desperate evolutionary hacks. Instead of sparse survivors, you'd find ecosystems layered like a thriving coral reef, but on land. Towering forests with symbiotic plants that fix nitrogen more efficiently. Insects the size of birds thanks to higher oxygen levels. And maybe even large herbivores that evolve intelligence faster because resources are abundant. Here's a relatable human story. Imagine a family of early settlers. Let's call them the Parkers, arriving after a multi-generational voyage. On Earth, they've trained in harsh simulators mimicking high gravity and variable climates. But landing on this super Earth, the air feels invigorating, like stepping into a spring morning after a long winter. The 5 degrees Celsius warmth means milder winters, longer growing seasons, and perhaps no need for massive heating systems. Their crops' genetically tweaked Earth varieties yield triple because of richer soils from active geology. But challenges arise vividly too. One settler, a botanist named Lena, notices plants growing faster than expected. She documents a vine that climbs structures overnight, inspired by Earth's kudzu, but engineered by nature for even better carbon capture. Her team encounters superbugs insects with exoskeletons reinforced by the planet's gravity, yet harmless pollinators because the ecosystem balances predators perfectly. It's not all paradise. A sudden storm, fueled by the extra warmth and water vapor, floods their camp, teaching them that better doesn't mean risk-free. They adapt by building elevated habitats inspired by mangrove forests back home. Another example draws from Earth's extremophiles. Tardigrades, those microscopic water bears, survive space vacuum and radiation. On a superhabitable world, similar tough microbes might have evolved into macroscopic forms earlier, creating soil teeming with life that enriches everything above. Think of how Amazonian soils, despite being nutrient-poor, support incredible diversity through rapid recycling. A superhabitable planet could amplify that globally. These scenarios aren't just fun speculation. They force us to confront anthropocentrism. We assume better for life means better for humans. But a superhabitable world might favor different biochemistries, maybe silicon-based or ammonia solvents in edge cases. Or it could be so lush that invasive Earth species disrupt the balance, turning us into the problematic newcomers. Real-life parallel. Australia's introduction of cane toads, meant to control pests, instead devastated local ecosystems. Colonizing a superworld would require extreme ecological humility, diving deeper into candidates without copying specifics. One intriguing prospect orbits a star system potentially billions of years older, sitting in its habitable zone. Its size edges toward the upper limit, and which could mean robust geology, but risks of a single massive supercontinent with arid interiors. Think Pangaea on steroids, where coastal zones become biodiversity hotspots, while the heartland turns desert. With the right greenhouse gases, temperatures could sweeten to that ideal warmth, fostering richer life than Earth's ice age interrupted history. Another candidate, farther out, might circle a cooler yellow dwarf, placing its orbit closer in but receiving comparable energy. This setup could stabilize seasons differently, perhaps with gentler axial tilts reducing extreme weather. Yet proximity raises tidal concerns. If locked or slowly rotating, one side might bake while the other freezes, confining life to a twilight terminator belt where temperatures moderate. Imagine ecosystems there evolving like Earth's deep-sea vents but on the surface, chemosynthetic bases supporting complex food webs in perpetual dusk. A closer one, relatively speaking, still hundreds of light years, orbits a tiny red dwarf. Its year lasts mere days, and likely locking it tidally. Life would cluster in that narrow habitable strip, perhaps with organisms migrating daily or evolving sophisticated thermoregulation. Real insight. This mirrors Earth's own history of snowball periods, where life clung to equatorial refugia before exploding outward. A superversion might accelerate that recovery. These examples make the abstract vivid. One settler story I love imagining. A young explorer, born en route, steps onto the Terminator zone. The sky glows in eternal twilight, hues pinks and golds from the stars' position. Bioluminescent flora lights the ground like fairy lights, and creatures with mirrored skin reflect scarce light efficiently. She feels lighter or heavier depending on mass, adapting her gait like astronauts retraining after microgravity. It's not vacation muscle strain. Plants might produce unfamiliar allergens, but the sheer vibrancy inspires art, science, and philosophy back home via delayed signals. Critically analyzing this hunt reveals optimism mixed with caution. Superhabitability assumes life follows Earth-like rules, carbon-based, water-solvent, needing sunlight or chemical energy. But what if agidic biochemistries dominate? A warmer, older world might foster faster evolution, leading to intelligence sooner, but also to fiercer competition or rapid extinctions if stability falters. Technological barriers dominate discussions. Even the nearest candidates require travel times spanning millennia with current propulsion. We'd need breakthroughs in sails propelled by stellar light, advanced hibernation, or closed-loop ecosystems sustaining generations. Psychologically, crews might diverge culturally, as isolation breeds innovation or conflict, echoing how isolated human societies on Earth developed unique worldviews. Environmentally, a stronger gravity could reshape biology. Stockier builds, reinforced bones, or multi-limbed adaptations for mobility. Plants might grow shorter and sturdier. For humans, pre-mission jacking up via training would be essential, but long voyages risk muscle atrophy anyway. It's a reminder that space isn't just about rockets, it's about re-engineering humanity itself. Pursuing superhabitable worlds reframes our climate crisis. Instead of despairing over Earth's flaws, we see them as lessons. Earth's average status pushed life to innovate resilience. Superworlds might cradle life more gently, but perhaps we've earned our toughness. Plus, discovering one wouldn't mean instant relocation. It would first revolutionize astrobiology, bioengineering, and our search for biosignatures like unusual gas mixes. oxygen plus methane imbalances hinting at biology. How? In wrapping up, superhabitable exoplanets represent hope amid cosmic vastness. Candidates with optimal age, size, and temperature profiles could host biodiversity surpassing Earth's rainforests or coral reefs, offering stable havens where life doesn't just survive, it celebrates. Yet the journey underscores a profound truth. We must cherish and protect our own planet first. It's the only one we can reach in a lifetime. The clear lesson? Exploration expands our perspective, but stewardship defines our legacy. Don't wait for a distant paradise. Build sustainability here while advancing the tech to one day visit these wonders. Whether we find life or not, the search teaches humility. The universe likely holds surprises that challenge everything we assume about better. Start small, support space science, reduce your footprint, and then stay curious. Who knows? The next generation might decode a signal from one of these worlds, proving we're not alone, and that some homes out there might just feel like upgrades. What do you think? Would you relocate to a super Earth? Drop your thoughts below, like if this sparked your imagination, and subscribe for more cosmic what-ifs. Thanks for watching. Keep looking up.